We humans, including animals and plants, and all the living things we can see in this world, are doing their own jobs. We brush our teeth, we wash our hands, we watch TV while eating popcorn, or we just play video games when we're bored. But have you ever given thought to what we are made up of? Some legends suggest that gods and goddesses gave us form using clay to walk this earthly realm. But a lot of scientists conducted researches a long time ago and found out that we are all made up of atoms. But what are these atoms? Atoms, the basic unit of a chemical element which consists of three subatomic particles, namely protons, electrons, and neutrons. Each subatomic particle has a composition of alpha, beta, and gamma particles. For the protons, it is a subatomic particle with a positive charge, while the electrons has a negative charge. Neutrons, on the other hand, is neutral or does not have any charge. Dalton's theory. Elements are composed of extremely small particles called atoms. All atoms of given elements are identical. Compounds are composed of atoms of more than two elements. In any compound, the ratio of the number of atoms of any two of the elements present is either an integer or a single function. A chemical reaction involves only the combination, separation, and rearrangement of atoms, and it does not result to creation or destruction.
Law of definite proportions. The law of definite proportions state that a single chemical or compound, such as H2O or CO, the ratio of its component elements is a fixed whole number ratio. Law of multiple proportions. The law of multiple proportions state that two or more elements or compounds have multiple ways of combining into different compounds. Law of conservation of mass. The law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction.
Different atomic theories and models. First one is John Dalton's solid sphere model, 1803. Stated that atoms are indivisible and compounds are combinations of different types of atoms.
J.J. Thomson's plum pudding model, 1904, shows the atom as composed of electrons scattered throughout a spherical cloud of positive charge.
Ernest Rutherford's nuclear model, 1911. It stated that atoms are mostly empty space with a positive charge concentrated in the nucleus.
Niels Bohr's planetary model, 1913. Electrons moved around the nucleus in orbits of fixed sizes.
Molecules. Aggregates of at least two atoms in a definite arrangement held together by chemical forces or bonds, joined in a fixed ratio. Electrically neutral or stable. Types of molecules. Diatomic. Composed of only two atoms of the same or different chemical elements. Example: H2, O2, and CO. For the next type is polyatomic. Electrically neutral groups of three or more atoms held together by covalent bonds. Example: H2O, CO2, O3, and CH4.
Ions. Ions are molecules that have a net electrical charge. They either have a positive or a negative charge. Monoatomic ions. Monoatomic ions consist of one charged atom. Example: Na positive and Cl negative. Polyatomic ions. Polyatomic ions are ions that contain two or more elements.
Naming chemical formulas. Binary compounds. Usually the same as empirical formula. and contains only two elements, such as metal cation and non-metal anion. Ionic compounds. Metal forming only one type of cation. Name the metal first, followed by the non-metal, which has been modified to its identifying stem name plus the suffix IDE. For example, the symbol Br is an element bromine, which is transformed to the anion name bromide. For the second example, the symbol F is an element fluorine and transformed to the anion name called fluoride. For example, the element Fe2 positive has a stock name of iron 2 and a classical name of ferrous, while Fe3 positive has a stock name of iron 3 and a classical name ferric. For the second example, the element Cr2 positive has a stock name chromium 2 and a classical name chromus, while Cr3 positive has a stock name chromium 3 and a classical name chromic. Covalent compounds. Compounds formed between non-metal or molecular. Elements that occur first in this series is written and named first. The name of second element will retain its suffix IDE. Latin or Greek prefix is attached to the name of the non-metal element to indicate the number of atoms of that element in the compound. For example, N2O3 has 2 nitrogen and 3 oxygen. Therefore, its chemical name is dinitrogen trioxide. For the next example, CO2 has 1 carbon and 2 oxygen. Therefore, its name will become carbon dioxide. Acids. Certain binary hydrogen compounds, when dissolved in water, form solutions that have acid properties. These compounds are given acid names in addition to their regular IDE names. Binary acids is equal to hydrogen plus non-metal element. To name a binary acid, place prefix hydro and suffix IC to the stem of the non-metal, then add acid. For example, HBr is called hydrobromic acid, while HI is called hydroiodic acid. Note that not all binary hydrogen compounds are acids. For example, methane, which is CH4, and ammonium, which is NH4.
Polyatomic ions are ions that contain 2 or more elements. Polyatomic compounds that contain oxygen are called oxyanions and generally have the suffix -ate and -ite. The ate form contains more oxygen atoms than the ite form. However, if hydrogen is present in the compound, you will change the suffixes from ate to -ic and from ite to -us. There are 4 variations of anion names in these polyatomic compounds. For the first one, you will add the prefix hypo and the suffix -ite. For the second one, you will add only the suffix -ite. For the third one, you will add only the suffix -ate. And for the fourth one, you will add the prefix -per and the suffix -ate. With each of these compounds containing less to more oxygen atoms, respectively. For polyatomic ions containing hydrogen, you will first add the prefix hypo and the suffix -us plus the word acid. For the second one, you will add only the suffix -us plus the word acid. For the third one, you will add only the suffix -ic plus the word acid. And for the fourth one, you will add the prefix -per and the suffix -ic plus the word acid. Following the same examples as the anion compounds, with each of them gaining more oxygen atoms respectively. Acids. Acid formulas often begin with hydrogen. Inorganic compounds containing hydrogen, oxygen, and one other element are called oxyacids. In naming these oxyacids, hydrogen is the first element in the compound's formula, so you don't have to state it when naming the compound. The second part consists of a polyatomic ion containing oxygen. To determine the acid, the polyatomic ions should be examined. It is modified in the following manner. 8 changes to ik, while 8 changes to us. For example, H3PO4 will be phosphoric acid, H2SO4 will be sulfuric acid, HNO3 will be nitric acid.
Now we know that living things and non-living things are made up of atoms, molecules, and ions. Even though they are small, we could appreciate their significance. Thank you for watching.